Good day, learners. I am teacher Jessica Alcaraz Sungguad, your teacher in statistics and probability. We are in quarter 4, week 4, and for week 4, we will be talking about hypothesis testing concerning means for large samples. We have 3 learning competencies for this week, which can be seen in your learning activity sheets. For the Explorer, you're going to find the z-value of the following data. Write your answer in your notebook and check your answer with the answer key at the end of the activity sheets. You are given with the null hypothesis, test statistic, alternative hypothesis, and the critical region in testing a hypothesis for large samples. You are also given with the z-value for two-tailed and the z-value for one-tailed. In example number 1, so for the solution, our null hypothesis is mu equals 15 kilogram. Our alternative hypothesis is mu not equal to 15 kilogram. For the level of significance, we have alpha equals 0.01. For the critical region, you have z sub alpha over 2 less than negative 2.58 and z sub alpha over 2 greater than 2.58. Now, to find the critical region, identify the level of significance and the alternative hypothesis. So if it is two-tailed, left-tailed, or right-tailed. In the example number 1, so it is two-tailed. So we divide our alpha, which is 0.01 by 2. That will give you 0.005. So with that, that will give you a z-value of positive negative 2.58. So for the test statistic, identify the given. So our mean is 14.8, our mu null is 15, our standard deviation is 0.5, and n is 40. Substituting the given to the formula, which is c equals mean minus mu null divided by standard deviation over square root of n. So that is equal to 14.8 minus 15 all over 0.5 divided by square root of 40. So that will give you negative 0.2 divided by 0.5 over 6.32, and that is equal to negative 0.2 over 0.08, and that is equal to negative 2.50. So our decision, so we have to accept the null hypothesis. So meaning there is no enough evidence to reject the null hypothesis. So we accept the null hypothesis because negative 2.50 is greater than negative 2.58 and do not lie in the critical region. So by the way, our conclusion is there is no enough evidence to reject the null hypothesis always, because the null hypothesis is formulated for it to be rejected. But since from our computation, the resulting value do not lie on the critical region, so therefore we cannot reject the null hypothesis. For example number 2, our solution. So our null hypothesis is mu equals 48 months. Our alternative is less than 48 months. Our level of significance is alpha equals 0.10, and our critical region is z less than negative 1.28. So since it is left-tailed, so we identified the z-value using the table for the left-tailed, and that will give you z less than negative 1.28. So for the test statistics, we have the given, which are mean equals 45, mu null is 48, standard deviation is 12, and n equals 60. Substituting to the formula, which is mean minus mu null divided by standard deviation over square root of n, that will give you 45 minus 48 over 12 divided by square root of 60, and that is equal to negative 3 divided by 12 over 7.75, and that is equal to negative 3 over 1.55 equals negative 1.94. So, since negative 1.94 is less than negative 1.28 and it lies in the critical region, so therefore we reject the null hypothesis. So our decision is reject the null hypothesis and therefore conclude that the mean life expectancy of the battery is less than 48 months. For the engage, you're going to solve the given problem. Write your answer in your notebook and check your answer with the answer key at the end of the activity sheet. For the apply, which will serve as your assessment, you're going to write your answer on a yellow paper. So you have 5 items, multiple choice test, and a problem solving, which is equivalent to 10 points. Again, I keep on reminding you, avoid copying from others. That ends quarter 4, week 4. Thank you and God bless.